Hello everyone, I welcome you all in this lecture of Engineering Graphics and Design. Today we want to discuss on chapter number 4 projections of points and line, particularly topic 2 projection of lines. In last lecture we discussed about the number of cases of the line with reference to HP and VP and how its projections on vertical plane and horizontal plane. Today we will take some drawings with numerical values. Suppose our first question is a line AB is 80 mm long. It is inclined at an angle 45 degree to horizontal plane and 30 degree to vertical plane. The end day is 20 mm above horizontal plane and 10 mm in front of vertical plane. Draw the projections of line and also write the elevation length and plan length. So we have a data from these questions, given data in which the capital AB is equal to 80 mm, means the true length of the line is 80 mm. The location of point A is given, which is 20 mm above HP and 10 mm in front of VP, means point A is in first quadrant. Okay, so we already know what is the projection of point when point is located in first quadrant. Now theta is given. Theta is known as the line inclination with horizontal plane, and the line inclination with vertical plane is phi, which is 30 degree. So this is a example regarding case number 6 when line is inclined to both the reference plane HP and VP. So its front view and top view both are less than true length. Now interpretation is like this: true length AB, it is also AB0 equal to A dash B0 dash is equal to A dash B1 dash is equal to AB2 is equal to 80 mm. A is 20 mm above HP means the A dash front view is 20 mm above the XY line. A is 10 mm below XY because A is 10 mm in front of VP. Theta 45 degree means the line true length A dash B1 dash is at 45 degree inclined to XY line, and phi 30 degree means AB2 is at 30 degree to XY. Now this is our solutions of this problem. So how to start your problem of projection of line? So first of all, we have to draw a line XY. This XY line is known as HP when you observe front view, and XY is known as vertical plane when we observe top. So here XY represents in two different planes for different view position. Now start your problem with projection of A. So A is 20 mm above, means small a dash is 20 mm above XY, and after A dash A, we have to draw one horizontal line from A dash and horizontal line from A. Because true length is 80 mm and theta 45 degree, from A dash we have to draw one line. First this true length 80 mm and angle 45 degree, and locate B1 dash. Then from B1 dash draw horizontal line parallel to XY, which is known as locus of B, and from small a top view draw phi angle 30 degree and true length which is 80 mm, and locate B2 points, and then again draw the horizontal line which is known as loci of B. So now we have loci of B dash and loci of B, on which we will get the front view of B and top view of B. So how we'll get the B dash and B? So for that we have to draw one vertical line from B1 dash up to horizontal line of A, which is known as B1, and from B2 draw vertical line up to horizontal line of A dash, which is known as B2 dash. Now, with the use of compass, A dash center, A dash B2 dash radius, and draw arc up to intersection of horizontal line of loci of B. And the intersection of these two, line and arc, is known as B dash. So join A dash B dash, which is elevation or front view. Now from B1 dash, draw vertical line up to horizontal line of A, which is denoted by B1. And now with the use of compass, take center A, radius AB1, and draw arc from B1 up to intersection of this horizontal line, which is known as loci of B or locus of B. So the intersection of this arc and this horizontal line is small b. So join small AB, which is known as plan, and A dash B dash is front. Now keep in your mind always A dash A and B dash B both are in single vertical line. A dash A vertical line, B dash B vertical line, and these two vertical lines are always parallel to each other. So in these questions, we have to find out the elevation length and plan length. So when you measure with the use of scale, the distance between A dash and B dash, which is front view, 69.3 approx, and top view small ab, plan length 56.5. So these are the answers. Next problem, top view of a 75 mm long line is CD measures 50 mm, and C is in HP and 50 mm in front of VP, and D is 15 mm in front of VP, and it is above HP. Draw the projection of line CD. Find the angles with VP and HP. So in this case, our given data in which we have the true length of CD 75 mm, plan length, the position of C with reference to HP and VP both, and the position of D. So first of all, you have to draw an XY line, okay? Then use the location of C. C is on HP and 50 mm in front of VP. So our front view of C on XY C dash, and top view small c, which is 50 mm from XY. After locating C dash and C, because we have a true length and position of D. D is 15 mm in front of VP. So from XY, you have to take 15 mm distance and draw one imaginary line. This is known as loci of D. Now C center and true length 75 mm radius. Draw the arc on this line, which is denoted by D2. Join C D2, which is true length. Okay. Once you draw C D2, you can draw an angle 28 degree. Now here D2 and small d both are always in the single lines, but we do not know the location of D top view. So how to draw this small d? For that, because the plan length is 50 mm, that's why C center 50 mm radius draw arc. Now D is available, so join CD, which is top view. Now we have D2D. Now draw the vertical line from D as well as draw arc from D by taking C center. So we'll get D2, then draw vertical line. Now on this vertical line, you have to take compass, C dash center 75 radius, draw arc, which cuts on this vertical line at D1 dash. Now draw horizontal line which intersects on this vertical line, is denoted by D dash. Now join C dash D dash and C dash D1 dash. So here C dash D1 dash is true length and C dash D dash is elevation length. Now in these questions we have to find out two angles of the inclination with HP and VP. So here theta and phi both are our required answer. Let us see the front view of line and top view of line MN is inclined at an angle 30 degree and 40 degree respectively. The front view of line MN measures 50 mm, point M is 15 mm above HP and 10 mm in front of VP. Draw the position of line MN and find the true length of line MN. So in this problem, actually the angles are apparent angles alpha and beta. So alpha is known as apparent angle of front view with HP and beta is apparent angle of top view with VP. Elevation length 50 mm. Location of M is given. M is 15 mm above HP and 10 mm in front of VP. So M is in the first quadrant. So first of all, you have to take XY line. First of all, you have to take XY, then locate M dash and M because 15 mm and 10 mm are given. Now from M dash, you have to draw one line 30 degree alpha angle and the elevation length 50 mm. So now you have M dash. Now from M, beta angle 40 degree and draw one line because the length of top view is not given. So you have to just draw a line. Now the another thing is always N dash and N both are in single lines. So draw vertical line from N dash up to inclined line of M at 40 degree. The intersecting point is M. Now M center, MN radius, draw arc up to horizontal line of M which is N1 and from N1 draw vertical line. On this vertical line we will get the intersection of this horizontal N1 dash. Now join N1 dash to M dash which is known as true length. So here we have to find true length of the line. The answer is 61.8 millimeter. Now line CD has its end C is 15 mm above HP and 10 mm in front of VP. The end D is 60 mm above HP. The distance between the end projectors is 50 mm. The line is inclined to HP by 25 degree. Draw the projection and find its inclination with VP and true length of line CD. So data given. The position of C 15 mm above HP and C 10 mm in front of VP means C is in the first quadrant. D is 60 mm above HP. Distance between end projectors C and D is 50 mm and theta, the inclination of the line with HP is given 25 degree. So in this question, first of all, you have to draw XY line, then draw C dash C front view and top view. Now from C dash, we have to draw one line, but the horizontal line which is 60 mm above HP. So 60 mm above XY, you have to draw one line and true length is not given, but theta is given. So from C dash, you have to draw one line at theta 25 degree and this line intersect at the horizontal line which is 60 mm above HP. So we will get D1 dash and from D1 dash you have to draw vertical line up to horizontal line of C. Now end projector length is given 50 mm. So here C dash C vertical line and from that you have to take a 50 mm distance and draw vertical line. So this line in which D dash and D will come. So because D 60 mm above HP, you can locate D dash as 60 mm on this horizontal line. So C dash D dash is elevation length and on this vertical line the arc by taking C center and CD1 radius, draw one arc, intersecting point is T. Now join CD, top view, and whatever the true length here, 106.47, same true length is radius, C center, and draw arc here, locate D2. So by using CD2, the inclination angle with horizontal line is known as phi, and this is theta. So our answer is inclination of the line with VP 48 degree and the true length 106.47. Now one case of the line when line is parallel to profile plane. So a line is inclined to HP and inclined to VP at angle theta and phi, and the sum of these two angle is 90 degree, then always the line become parallel to profile plane. So in this figure, our line AB is inclined to HP, inclined to VP, and these two angles are theta and phi, and if theta and phi 90 degree, then line become parallel to profile plane. So a line parallel to PP, the front view of the line on vertical plane, vertical line, and top view of the line on HP, also vertical line, and left hand side view, the projection of the line on profile plane is always true length, A double dash, B double dash. So when we incline the horizontal plane 90 degree, profile plane 90 degree, our three projections on three principal planes looks like this. Here, the side view is always true length, and front view and top view means elevation length and plan length. Both are vertical and both are perpendicular to XY line. Now questions regarding this case, when the line PQ 70 mm long has its end P on VP, Q on HP, line is inclined by 60 degree with HP and 30 degree with VP. It is 20 mm away from profile plane, draw the projection of line. So the same case, our line AB, the angle of this line with horizontal plane is given 60 degree and the line with vertical plane 30 degree. So the front view of this line on vertical plane A dash B dash and top view plan on horizontal plane small a. So the projections on XY line, the left hand side view of the line on profile plane is true line. So how to draw on 2D? XY first, then the side view is true length, and for side view this line is known as inclination, the line inclined to HP at theta, and this angle is known as the line inclination with VP. So the sum of these two is 90 degree because 60 and 30, and the point P is on VP and Q on HP. So we have to trial and error method, or you can say you can start from a side view from one imaginary point Q1 double dash, true length 60 degree. So this is one temporary line. Now from this end point you have to draw one horizontal line up to x1 y1 line. So P double dash. Now from P double dash phi 30 degree, draw one line, or you can say draw the parallel to this one, draw line up to xy. So this is our final side view on profile plane. And for front and top view, you have to draw one line 45 degree from intersection of xy and x1 y1. Draw vertical line up to this and then horizontal line. And from front side view of P, draw horizontal line. And because 20 mm distance is the line from profile plane, you take 20 mm and locate P dash Q dash and PQ because our line is parallel to profile plane. So front and top view both are line. So thank you very much for watching this video, students. Thank you.